Alright, hi guys. I miss seeing you guys in class all the time. You're not participating well enough online to really feel like we're getting to talk to each other about any of this. So I noticed last week that there were a lot of questions about this whole greatest common factor when you had a variable involved, and so we're stepping it up a notch this week, and we're going to excuse me, turn it into a full-on polynomial. And so I need you to be able to do that really well. So I thought I'd make a video showing you this greatest common factor business. The other classes are going to be looking at a Khan Academy thing, but I wanted to really talk to you about this and dive a little deeper with you. So, goodness, last week they would have just said, here's 4x squared and 12x, and find the greatest common factor. And so Mr. Hebert showed you a way to make this little factor ladder, and that was really great. I want to turn this into a polynomial and talk about factoring this by taking out the greatest common factor. So I think we can get to both situations taken care of at once. And I also think I need this light to maybe let it kind of focus here to get rid of some of the shadowing. Alright, so just because I put a plus between it doesn't mean it's going to change at all. What I want to do is look at these two. I'm going to think about this with an area model. So I'm going to put it into my area. 4x squared and 12x are going to be on the inside. And I want to think about what number they can both be divided by. What is its greatest common factor of just the 4 and the 12? Well, 4, right? So we're going to put the 4 on the outside of the area model. But here's what's happening with the variables. This has x squared, which just means x times x. And this term has just 1x, just x. What do they have in common? Well, they both have 1x in common, and that is what is coming out. And so I think that was maybe the missing link. So we're going to talk about that a little bit today. Now, I want to finish factoring this with my area model. And so what I need to do is to figure out what I need to multiply by 4x to get 4x squared. Well, I need another x, don't I? And then what do I need to multiply by 4x to get 12x? I need a 3, and it's a positive 3. So this part is my GCF. It is the width of this box, and the length of this box is what is left over. So this polynomial factors into 4x times x plus 3. This is writing it by undoing the distributive property. What we did before was, when you saw it this way, we took 4x and multiplied it in. What I'm doing now is dividing this whole thing by 4x so it brings it to the outside. And this is what is left. So I'm breaking it apart instead of putting it together. Okay? So we're going to do that a couple more times. Don't panic. That's not the end. I have 3x to the third, y to the third, plus 6x y squared, minus 12x squared y. I'm going to do this with the area model again. I think it's a good way to begin this visualizing. Okay, I need big boxes here. I'm going to put 3x to the third, y to the third, and 6xy squared minus 12x squared y, all in my boxes. Those are my areas because they're the terms of the polynomial. Now let's look at 3, 6, and 12. What is their greatest common factor? Well, it's 3. Now let's look at these x's. One of them has, the first one has x to the third. This middle term just has 1x, and the last term has x squared. How many do those have in common? Only this one, right? So there's only one x in common, so that's the one that comes out. Let's look at the y's. I have y to the third, y squared, and y. So I'm thinking about how many y's do they have in common? Well, they only have one that's in common. Okay, and so that's the only one that's coming out. Now I just need to do my area model, just figuring out what do I need to multiply this by to get this term. Well, let's see, I've got my 3, but I need x squared, and I need y squared. Nice. For the middle term, and I'm just going to put a plus there, that'll help, I have to take it times 2. I already have an x, I don't need another one. And I have one y, but I need another y, so y is going to need to be in there. Alright, now what do I multiply 3 by to get negative 12? Negative 4. And how many x's will I need? One more. And how many y's? None. I already have all the y's I need. So when I factor this, I factor out the 3xy, and it leaves behind x squared y squared plus 2y minus 4x. So this is called the factored form. That's pretty neat, huh? Alright, let's try that again. I have 6a to the third b squared plus 18a squared b minus 24a. I would like for you to stop the video here and see if you can do that yourself. So just hit pause and try it again. Alright, let's try this. See how you did. I've got 6a to the third b squared, 18a squared b, minus, 24a. We fit. Alright, 6, 18, and 24 can all be divided by 6. I have one a in common, and I don't have any b's in common, so I will not be taking out a b. You see how he's missing one. You can't take a b out if it's missing one. Alright, so 6a times what? Well, I already have the 6, but I need a squared, and I still need a b squared. So these two should multiply to give you this area. Okay, plus 3 to get 18, one more a, and a b. Minus 4, oh, I have an a, I already need an a, and that's all I have. So to write it in factored form, I write it with the 6a on the outside, and the rest of it on the inside. I undistributed. I factored out the greatest common factor. Alright, I want to show you one more time, and this time I am not going to draw a box because some of you are ready to move on and not use a box for this. Okay, now if you want to use that box, you can use it until the cows come home. I do not care. But there are a few of you who are sitting at home ready to do this without the area model. You don't need the visual. Alright, so what I'm going to do is look at just the numbers and find their greatest common factor. I notice that they can all be divided by 4. So he's my greatest common factor. Now I also notice with the A's, I have 4 there, 1 there, and 2 there. So how many do I have in common? Just 1. Look at the B's. I've got 2 here, 1 here, and 3 here. So how many in common? Just 1. Now, on the inside, what is left over? So I need you thinking about, what am I going to multiply by? I need a 6. I have 1a. I need a to the 4th, so a to the 3rd. I've got one b, but I need b squared, so I need a b. Now here, I'm going to multiply by -2. I have one a, and that's all I needed, and I have a b, and that's all I needed. So I don't need any a's or b's with my -2. Next up, 4 times 3 is 12. I have an a, I need an a. I have a b, I need 2 more. Now, if you can do it this way, that's fine. You can do that, okay? But if you need to see it, if this is a good visual for you, then use it, okay? And when we do college prep and college algebra next year, for most of you, I'm going to offer that same opportunity. I'm going to show you how to do it without an area model and with the area model, and you can make a decision for yourself if you need it or not. Alright, so this is factoring out the greatest common factor, and every time we factor something, I want you to look for the greatest common factor first, and then you take that out and write what's left. So your answers just look like this. Okay? Now, I have a Quizlet that you can practice this on. It is completely optional, but if you feel like this is something that's going to take some practice for you, then you should go and try it out. You don't even have to do the whole thing, just try the ones that you think you need to until you think you've got it, okay? Alright, I'm going to get you another video about some other good factoring fun.